Hello everyone. I'd like to share a project I've been working on recently. I enjoy indoor climbing and occasionally want to record videos. When filming tall walls, the phone needs to be placed at an angle that can capture the whole route, and editing the footage afterward is tedious. If the camera could zoom in and follow the climber while recording, the video could be done in one take. I tried 2 smartphone gimbals, but when tilted upward at a large angle, they could not support the weight of the phone. I also didn't want to buy an all-in-one camera and gimbal, so I decided to build one myself. My solution has 3 components: a pan-tilt platform that holds a smartphone, a microcontroller for the motors. The phone does the filming, tracks the climber, and sends motor commands via Bluetooth. The mechanical design was based on an open-source DIY camera platform. Because there were too many details to adjust, I decided to model it myself. I used OpenSAD. With about 500 lines of code, I could define the geometry of all the parts and easily adjust the dimensional parameters. Next, I 3D printed all the parts. Assembly was the most enjoyable step. The electronic components include an ESP32 microcontroller, 2 TMC2209 stepper motor driver boards, and a trigger board for power supply. Connecting them with wires was very messy, so I needed to design a simple PCB and have it manufactured. The PCB manufactured by the factory looks like this. I needed to solder the sockets myself. It was very delicate work. Then I could plug in the electronic components. After connecting the motors and adding a power bank for power, the electronics were complete. The microcontroller programming for this project was relatively simple. It mainly involved setting up the Bluetooth commands and motor control. The most challenging part of this project was the mobile app. It needed image processing, person detection and tracking, motor control, zoom control, and Bluetooth communication. It also included gesture recognition, so the user could start and stop tracking remotely. For this part, I relied entirely on AI, specifically codecs. I didn't write a single line of code myself. Finally, it was time for a demo. Giving a thumbs up with both hands is the start gesture. Then the phone starts tracking and recording. This video is completely unedited. The camera movement, tracking, and zoom are all fully automatic. It basically achieved the goal I had in mind. In the interest of time, I'll play it at a faster speed. Although I didn't make it to the top, I was still happy with how the video turned out.